Okay, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to our lecturer, Professor Madia, IR Dr. Dirman. My name is Azmiza binti Manaf, and I would like to present about the introduction of our project. So, the problem background. The power quality will affect the blackout problem. This project showed that the possible power quality problem and how we actually overcome it by using a simulation software, which is a MATLAB software. So, a problem quality problem is a term to describe a voltage or current deviation from its ideal waveform. There is so many type of power quality problems such as sag, swell, and harmonic distortion. So next, the problem statement is we are trying to construct a transmission line system model in MATLAB software, and the method to mitigate the power quality problem can also be determined and observed by looking at the waveform formed by the output in MATLAB software. And we also analyze and let's discuss the result and find the realistic constraint. We actually present the impact of engineering solution to the society and environment sustainability. The objective of this project is to understand the characteristic of power quality disturbances and their causes. And we also actually identify the type of power quality problems, the cause, and how to overcome the problems according to power quality problem type. As we go into the project, we chose to, for example, we chose for the harmonic distortion, and we chose also the type of solution by applying the harmonic filter. So next, we also learn to construct a transmission line system using MATLAB simulating software. The scope of this project is focused on a transmission line system, and the waveform of the system were observed when power quality problem occur. And then we mitigate the disturbances by applying the solution of the power quality disturbances specifically. That's all from me. Thank you.
Assalamualaikum, my name is Nur Faradila Afiqah binti Hasan. My metric number DE180186, and I will explain to you the methodology part. Firstly, we will go through the flow chart. So to observe the power quality problem and to apply the solution, we design a transmission line system by using a MATLAB simulink. After that, we will set up the parameter value for the transmission system, such as for the generator, transformer, line, and load. After that, we will run the simulation and record the percentage THD for voltage and current. So if the percentage of THD for voltage and current is higher than 5%, the waveform of the voltage or current will be distorted. So to overcome the problem, we installing a harmonic filter as a solution to mitigate the problem. If the percentage of THD is below than 5%, that means the system is in normal condition. Lastly, we will analyze the final result of this system with and without usage of harmonic filter. Next, I will explain you the schematic diagram. So the single line diagram of transmission line, which consists of 3 bus and 2 generator. So this table below show the parameter that are set in the MATLAB solution by referring to the one line diagram. So next is MATLAB simulation. So this is the transmission line that are designed by using a MATLAB simulation software. It was designed to observe the percentage of harmonic occur in this system. So to apply it, to mitigate it, we apply a harmonic filter. So the tools and blocks that are used in MATLAB Simulink can be accessed in Simscape library. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Azrini binti Azhar. My metric number is DE180152. Okay, so let's proceed for the demonstration first. Okay, I would like to demo about a harmonic distortion problem. Okay, so this is our circuit, which is there is no solution yet. Okay, so we run it, and after we run, okay, the result will get voltage THD is 23.04%, while for the current is 1.81%. Okay, so the VTHD is so high in this case. Okay, so the waveform would be like this, which is a voltage waveform. Is in not normal, is a non-sinusoidal waveform, while for the current it's a normal sinusoidal waveform. Okay, so for this problem, I apply the harmonic filter for this problem to mitigate this harmonic problem. Okay, so for the result, okay, we run it and we got 2.38% for the voltage THD, and for the current is so low, which is 0.54%. Okay, which is, we know the allowable THD is 5%. Okay, so the voltage THD is in normal THD percentage. Okay, so the waveform would be like this, which is a sinusoidal waveform. Okay, so let's proceed for the result and analysis. Okay, the harmonic distortion. Okay, so this is the basic connection of transmission line, which is I show at first just now. Okay, so this is our result. Okay, so as you can see, the allowable percentage THD is 5% in any general system, which is distribution system, transmission system. It is 5% basically, plus minus 5%. Okay, so from a waveform, you can see a distorted waveform for voltage waveform drawn. Okay, so you can see the voltage waveform is a distorted waveform because of the THD percentage is so high. Okay, so the distorted sinusoidal voltage wave is due to the high percentage. Okay, so it is correct. Okay, so for the next part is harmonic filter. So the solution proposed by installing a harmonic filter in this transmission line to mitigate the harmonic distortion problem. Okay, so this harmonic filter is installed in between line and the load. Okay. So for the result for harmonic filter applied, the percentage is back to normal, which is below 5% in general system. Okay, so the graph of voltage and current is a sinusoidal waveform, which is in a normal condition and with less distortion. So the waveform would be normal with less distorted waveform. Okay, thank you.
Hi, Assalamualaikum. My name is Athira, Nabilla binti Omar, and my matric number is DE180172. So today I would like to explain about the discussion for this project. So basically, the harmonic distortion is the biggest problem for the power quality issue that faced for many countries, including Malaysia. It is become a serious problem due to increase the use of power electronics and converter in power system plant. The main cause of this problem is called as a non-linear load. A non-linear load that can be led to a non-sinusoidal load, current and voltage draw. For a total harmonic distortion must be expressed first using VTHD formula. Next, there are two main types of harmonic filters, such as passive and active filter. Passive filter is a series filter that current goes through the filter to mitigate the harmonic to a tolerable level. For the active filter is a parallel filter that current does not go through the filter that used to mitigate the harmonic distortion. For the next conclusion, my friend Nurul Shahirah will explain it. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur binti Hasan. My chemistry is DE180146. Now I will explain to you about the conclusion that we found in the project. Let me start. So the first conclusion that we found is the importance of power quality in power system is must in order to observe and maintenance from the power quality disturbance occurs. Next is the mitigate solution may help the power system to keep the system operate at safe and stable conditions. Next, students are able to understand the characteristic of power quality disturbance and their causes. For example, in this project, we found that the power quality disturbance is harmonic distortion. Moreover, students also able to identify mitigate strategy which could overcome the power quality problem in the system. Next, allow students to do simulation on transmission system when there is harmonic in the waveform by using MATLAB simulating software. So for the recommendation, use transformer with zero sequence component can be applied as the mitigate solution in transmission system. That's all from me. Thank you.